This is a bit experimental just because we never tried this before for Hyperledger Iroha. So we'll have to see how this works. But the idea is that we'll give a quick maybe some overview about the work that we're doing with Hyperledger Iroha in version 2 and 3. And yeah, maybe take some questions. Yeah, this is, like I said, a bit experimental because we don't know how it's going to go, and also it's a little bit awkward because we can't like do full like screen sharing and stuff. But this is something that is kind of like a preliminary space, and then later on we'll do, I think, a more formal presentation. So yeah, just get started. So nice to meet you. I'm Makoto. I'm one of the contributors to SORA and also to Iroha. And I work at a company called Soramitsu that I founded almost 10 years ago. And I think some of us are here on this call. So it's really great to see you take your time out of your Friday night to join. I want to talk a little bit about the work that we're doing here on Iroha because we're really at a turning point where a lot of things are starting to change and change quickly because we're putting out new technology that we have been working on for quite a while. So yeah, maybe I'll just start with I thought there's a way to share tweets, but I don't actually see. But yeah, maybe I can try to post something here. Maybe not. It doesn't work. Okay. Anyway, so Twitter has a lot of functionality problems that they could have a better usability. But I think I can tweet to this. I want to share this infographic that was made by our Clinker friends. About kind of the difference between traditional blockchains and then what we're trying to do here with Iroha 3. So I tweeted in response to this space, and yeah, just to kind of explain a little bit about where we came from and where we're going. We started working on Iroha back in 2016. The version 1, and we first announced it actually I think it was October of 2016, and in November it was accepted into the Hyperledger project, which then later became the Hyperledger Foundation, which then later became Linux Foundation Decentralized Trust. So it's been quite the journey. And Iroha 1 was good at some things, made it really easy to do things related to digital asset management, like creating tokens and sharing these tokens with others. That's why it's been used by the Central Bank of Cambodia in their Bakong project, because it's a system that's very fast and easy to create a digital asset kind of payment platform type of thing on. And Iroha 1, of course, was limited, but it was, I would say, purposely limited because we were trying to make it easy to do just the core use case and not to do things that would cause trouble. So what I mean is you don't want to have too many features in a financial system because it increases the attack space, right? You have to audit everything, and it makes it easier to find some kind of mistake if you have a lot of code and features. However, it was limited, but it was purposely limited. But quite quickly we found that it was maybe too limiting. We wanted to do more than just enterprise solutions. We wanted to do things more with the public DeFi and decentralized ecosystems as well. And Iroha version 1 was not really that very good at that. It wasn't made for it, right? Iroha 2 we started back in 2020, so 5 years ago, and That's where we added a VM, we added WASM initially, and we worked over time to expand the functionality of Iroha version 2. And we still continue to work on this now. We tested Iroha 2 with several central banks, including I guess including Laos and Solomon Islands, Papua New Guinea. We did the savings bond project for the Ministry of Finance of Palau, and we did many other exciting projects as well that I don't know if I can talk about or not. So we did some really cool things over the years with Iroha 2, but yeah, we also found that there's some downsides of using WASM. It's a bit complex. The builds are kind of large. It's also kind of limiting because you have to use no standard when compiling with WASM, and which means you don't get all the benefits that you get from the standard library in Rust. And that's where we got the idea, why not just make it's not such a light decision, but why not make our own VM? So that's where we started working on the new version of Iroha 2 and creating the Iroha virtual machine, which is what we announced the other day for SORA Nexus. And IVM is a new VM that's made from scratch. It's kind of learning from previous VMs like of course Ethereum, but also Risk and or Risk-like VMs, and also things like Solana's extended Berkeley packet filter. And you might be thinking, why not just use one of these existing VMs? Like Solana just is taking eBPF and it's not making its own solution. Well, things like EVM are quite old. So EVM is more than 10 years old now. And the Berkeley packet filter and extended Berkeley packet filter were not really made for blockchains. They're made more for for like things like routers, and they're quite old too. So they weren't really made for the purpose. And yeah, you could do something like Solana did and hack it together, but it's not really that great. So we decided to go with some like new improvements based on what we could see and learned, especially from the experience of Ethereum, and also our own experience working in the Polkadot ecosystem for a while and using WASM. And we found that using something like similar to eBPF, where you have a register-based VM, is good. It makes things maybe easier to do some types of parallelization, and but at the same time, we also wanted to make it kind of flexible, not too hard to work with. So what we ended up doing was making our own VM, and it made it register-based. It has strict types. We got rid of floating point, so there's no floating point math errors that are possible because there's no floating point numbers. There's no non-deterministic system calls, and everything is bit for bit identical, regardless of the hardware that's used. And we also allow for some parallelization and even hardware acceleration, but again, only where there's bit for bit results. So that means that if you have kind of, for example, unrelated transactions, you can actually execute these transactions in parallel. So non-overlapping transactions can be scheduled into parallel cores and run without risking any conflict. And at the end of the block production, it'll actually have the same results. So blocks you can kind of think about as like as kind of a miniature like deferred net settlement system, where blocks are kind of like doing small batch processing in a way. Like even if it's like 1 second each, it's still doing things like in a batch. So if you have the right annotations and kind of pre-analysis, you can parallelize it. So that's what we do. so we made our own smart contract language called Kotodama that is compiled to IVM bytecode. And Kotodama, as part of the compiler process, will actually annotate the bytecode with a list of things like system calls that are used and opcodes that are used. And so it's able to take this kind of pre-analysis work and then parallelize it if there's no conflicting opcodes. And I'm pretty sure we can also increase the parallelizability in the future as well. Some things we use hardware for too. So some types of crypto you're able to execute on hardware. By hardware I mean like some types of GPUs, and then also we support like some special vector math and things like this that some CPUs support as well. So this allows for pretty good performance. In some cases, you can get like 30 times performance by using these hardware methods. So it's pretty good. And if you fine tune it, you can get even like 100 times performance depending on the type of work that's used. So Iroha 2 and Iroha 3 are going to be using the IVMs from now on. So you might be thinking, what is the role of Iroha 2 now, and like what is Iroha 3? So Iroha 2 is not gone, even though that there's number 3. The plan is that there's going to be just one repository of source code that manages both versions 2 and versions 3, and we will just have build scripts that will build the different versions, because version 3 has different features than version 2, of course. So version 2 is more like a traditional enterprise blockchain where you have some kind of private validators. I mean, in theory, I think we also support nominate proof of stake in version 2 nodes as well. But the idea is that you have your own like small little network, whereas in version 3, we decided, hey, let's just have one network. So this is kind of a shift in thinking from what people have had up until now. So, SORA Nexus is using Iroha 3, but it's not only using Iroha 3, it is Iroha 3. So what I mean is there's only one instance or one instantiation of Iroha 3, and that's SORA Nexus, because SORA Nexus is infinitely scalable. You don't have to have more than one blockchain. Like it's just Iroha 3. That's all you need. It's just one blockchain. It's called SORA Nexus, and it's a global ledger for the entire world. And the goal is 1 second finality, data sovereignty, and post-quantum security. So that sounds like a lot of stuff, but what we're doing is really quite targeted. And you might think about, what are some of the problems that we have with existing infrastructures where people have lots of different chains or different L1s, L2s. So some of the problems are you can have, so you have this kind of trade-off between interoperability and, you could say composability and sovereignty. So up until now, if you want to have some kind of composability, you have to like share data, right? So if you want to create a token on one chain, you kind of have to share it to another chain and then move things around. There's also the problems with like predictability of performance, like one chain or one app, if it got to be really popular on a chain, could slow down all the other transactions for the rest of the chain. So even though, for example, Solana, doesn't really have this interoperability or composability problem because they do everything on one chain, if they did have any kind of bug or any kind of really super popular app that slowed down and used all the bandwidth, that would actually hurt the entire system, and that's not good, of course, if you want to build on a network. And if you try to split everything to like app chains or L1s or L2s or all these things, you create really isolated silos that you can still do some types of transactions between them, like with bridging, but this is not a really good user experience, of course. So finally, you could say that if everyone is using their own networks and stuff, there can be too much fragmentation. So in the CBDC space, there's around 130 central banks looking at central bank digital currencies right now. And, some of them are in production, some of them are testing things. And if you wanted to have interoperability, you really have to build it in from the beginning, because you might think, what's the big deal? Just build a bridge later on. But that's not really how central banks work. So central banks are very conservative. As an example, the Bank of Japan, just to extend the settlement window of Japanese government bonds by 5 hours per day, they spent more than 6 years doing this. So, and I don't even want to know how much money it costs to do that. So, central banks are really conservative. They can't afford any mistakes, and so changing systems once they're in production is very, very difficult. And so, our solution to all this is to create one blockchain. So from that standpoint, we're similar to Solana, because Solana also takes this idea that you have just one blockchain. But what's really different is the data sovereignty standpoint. So Solana makes you do everything on Solana, but in some jurisdictions, you're not allowed to move transactions out of the physical borders of a country. So that's very common actually for financial transactions. So because of that, you actually need a set of servers or nodes that or validators that are within the country, and they process the transaction and don't leak any information. And this is definitely at odds with composability. But the solution we came up with was to take one. The whole world is one logical ledger. Where basically, if you have an account on the ledger, some key generated, it'll just work with the ledger. So if you have like a CBDC in one country, you have an account like in every other data part of the system. And to give the sovereignty to central banks and to others who need it, you split this ledger into data spaces. So a data space is really just some part of the ledger that can have a different physical infrastructure. So, for example, if you have this big logical ledger that's a SORA Nexus, maybe part of the ledger, part of the data is managed by different physical nodes in other parts of the data. That's really how you get like infinite scalability. Is you don't force one computer to do everything, of course. So. Don't tell the Mega ETH guys, but I'm joking. But, well, kind of. But yeah, you really have to have it so that the system can process things as one logical unit, but with different physical infrastructure. And that's what we created. And to glue everything together, we use ZK Starks, zero knowledge, scalable, transparent arguments of knowledge, which we just use like normal ZK Stark framework. We created an implementation called FASTPQ that is pretty fast. And I'll talk about this more in a moment. But we also added kind of this dynamic, it's not sharding per se, but we added dynamic consensus lanes. For example, in Polkadot, you really just have one consensus lane on a substrate or a Polkadot network, like SORA version 2, for example. So if you create a transaction, it just gets processed on the same network as part of the same consensus. But what we do in Iroha 3 and / SORA Nexus is we have different consensus lanes. So you can think of it like kind of like a highway. Like if it gets really busy, you add more lanes, and you get more throughput, of course. So basically, each data space can have multiple consensus lanes, and this allows you to do things that maybe are slow from a consensus standpoint, but you don't want to do them like off chain, but you also don't want to hold up block production. So this allows you to create multiple consensus lanes, like some for some types of transactions and some for others. An example would be like in Polkadot, if you want to do a bridge, for example, you can use like an off-chain worker that will check is this Ethereum transaction process? Does it have like 30 or whatever block confirmations? Like this is done kind of off chain, but there's a lot of disadvantages to doing it off chain. It's kind of a fragile solution. You have maybe governance becomes harder because people who are running things off chain are not maybe the same validators. And so what we do in SORA Nexus is you can just create your own like a lane, it's called, like a special lane for doing this kind of slow processing. And then this will, if it creates a block and it's taking too long and it misses a cutoff for a given block, it will just, system will just make the next block. It won't wait for it, but it'll wait for the next, in the future when the data processing is done, it will just automatically give it to the global merge. It's called a merge layer, but once it gives to merge layer, it will actually merge it into like the final consensus set. And this is dynamic too. So if there's certain on-chain metrics that look at the amount of amount of the capacity that's full on a lane, and if it's consistently at capacity for some time, it will automatically start up a new lane, like for that data space. But this also increases latency, because if you have multiple lanes, you have to kind of merge blocks together and all this. So you don't want to have too many lanes. So once you if the users fall off, you would automatically delete some of these lanes. And so it's a dynamic system that moves things up and down as needed to meet capacity, which I think is a pretty good solution. And that's even within a single data space. And then to prove things to other data spaces, you're using the zk-stark, which is FASTPQ. So how does FASTPQ work? Well, it's actually, zk-starks are a little bit complex, but the basic idea is that you have constraints that you represent basically as matrices, or some kind of is math. And a constraint would be, for example, that the transactions that you do, the balance can't be negative or can't go to negative. So in other words, you can't spend more money than you have. Like that would be like one of the constraints. You could even do business rules built in, like, for example, you could represent that everyone has to have done KYC and be able to prove their identity. This would be one of the constraints that you could set up. And then the way the zk-stark works is you do kind of like a random linear combination of all these to create a polynomial. So you create random weights because you don't want to like show the exact output from you don't want to show the output of the constraints, because then you leak data. So what you do is you randomly weight each constraint, and then you sum these to get a composition polynomial. And if this is a low degree polynomial, then basically all the constraints have been met. And if it's high degree, then something has been violated, but you don't necessarily know what has been violated. So this way you can kind of prove the correctness of a set of transactions that everyone knows what these rules are. They know that, so these are publicly known, so you can't cheat. But you don't actually know what the exact data are. So this allows for interoperability, and you can even architect direct atomic transactions between the data spaces, because we're all in the same ledger, right? So you can, if you want to do currency swap from one central bank digital currency on one data space to a currency of another data space by using a third data space as the exchange or foreign exchange provider, basically the way it would work is you could have an atomic cross-chain transaction that you'd use this lane concept where you wait for the proofs of both sides of the transaction to come in to prove that the currency has been transferred to some designated account. And once the proofs are all there, this actually is what is validated at the global layer. So at the global layer, there's a set of global validators run by nominate proof of stake that will sign off, validate and sign off on the transactions and create the blocks. So that's kind of what we created. So we have some other things too. So scalability is not only about computation, it's also about data. And we've seen this in some other systems that we built, even in SORA 2, to have all the transaction data is quite hard on a single computer. But it's important for archival reasons that you have good data availability. And so basically what we did was we created a system where you can shard the data using basically like erasure coding, but we use two-dimensional erasure coding that's a little bit more secure, and I would say stronger against correlated failures, which is important because lots of people use AWS, for example. So you don't want to necessarily just use a single erasure coding. So erasure coding is a way, for those who are not computer scientists, just a way that you can split up some data into like multiple chunks, and then you have some guarantees that you have high redundancy for the different chunks. So if a certain amount of computers on the network go away, that you don't actually lose the data. So this is quite important. And this is the data availability layer with reliable broadcast that we built in. And the DA layer also is quite interesting because it allows us to do other things on top of the network. So you can overlay different applications directly on SORA Nexus. So what that means is you're not limited to just on-chain transactions. Because you have all these validators creating like a network infrastructure, you can use them for things like data streaming. You can use them for like even like hosting websites and apps. You can do computation on them. So all this is done in a highly reliable way, and it's also built so that you basically pay per use using Zor. So like if you could stream videos or even calls like this could be streamed. In fact, we have anyway, I'll talk about it later, I guess, but there's even a broadcast tool that we built in called Taikai that allows you to broadcast like things like this or some kind of like event. And that is just using this the extra capacity bandwidth that validators have, and they get paid for it basically. So there's a lot of cool things. Not going to go into all the details today because I want some of it to be a surprise as well. Maybe I'll mention a few things about consensus. In the current implementation, consensus is a nominate proof of stake Sumeragi consensus, meaning that you nominate validators, then validators go through a sortition process to choose a subset of validators, and then these validators are then the ones who finalize the block. And then this set of validators is used for like a epoch, and then it changes like after some amount of blocks to get new validators. And we of course use verifiable random functions, so you can't guess who's going to be a future validator per se, and you can't game the system, which is, I mean, of course, it's a very important property to have. What else do we have? We have lots of stuff built in. We have what are called Iroha special instructions. These are basically like opcodes in the IVM. So you can compute any kind of function in IVM because it's Turing complete, but you don't necessarily change the world state. You change the world state through the opcodes that are in the IVM, also called Iroha special instructions. So things like minting an asset would be one of these calls that then this changes the data state. So like this is pretty different from Ethereum. So in Ethereum, each contract like has their storage, and like so in ERC20 token, contract just has like a list of account balances and like or a list of accounts and balances for some token, right? And then you have functions inside the contract that are moving this from one account to another, and every ERC20 token just like copies all this. So it's quite inefficient, well, to say the least. It's pretty wasteful. And so in the IVM, what we have are each account is in the world state view. So like there's a global world state, which actually is using data availability layer. So it doesn't have to fit on a single computer. You can actually have it sharded. So that way you're not limited to the number of users. So there could be, any number of users, like trillions of users. I don't know, like maybe the space aliens can use it. I don't know. So basically, you're not limited in any practical terms for the number of accounts, and each account has some like asset balances, and this makes it really easy to like find out like all the assets that that user has, and be able to do analytics and things like this for normal transactions. So when you execute an IVM program, you could actually execute an IVM program and not change any of the world state. You could just do computation and waste your time and pay for it. But if you want to change the world state, you have to call some of the Iroha special instructions, which this makes it more secure because it means that all the state transitions are happening through a defined set of opcodes, basically. We have our own data serialization format called Norito. We have Kotodama I talked about. We have triggers, so you can like set up automation and do things that are time-based or event-based. We have Parliament. So the SORA Parliament is implemented now for Nexus. So the full thing has been built. We have basically implementation just like in our Medium article from 2020. Yeah, 2020. Called about the SORA Parliament. So in SORA Parliament, there's different, for those who don't know, it's like a multi-body sortation governance structure. So what does that mean? Well, okay, so people when you go to school, you don't really learn about the world. The whole point is like to just kind of make people kind of easily adaptable to society. But if you actually study like the history of democracy, you'll find that real democracy was, especially in Athens, was very different from what we know about today. And basically, it was based on three types of concepts. Like one is isonomia, isegoria, and sortition. So isonomia really was the principle that anyone who's a citizen has a equality politically, like political equality. So if you're a citizen, you're basically the same as any other citizen. Isegoria is the right of all citizens to speak and contribute if they want to. So if you want to contribute in the decision-making process, you can contribute your opinion. It doesn't mean that people are going to follow it, but at least you can share some ideas. And then sortition is randomly choosing a group of citizens to make decisions. And this is important because this is similar to how blockchain consensus works. You randomly choose the decision makers in order to prevent cliques from forming or some kind of corruption. And this is like a one-time thing for each decision. It also makes the system scalable because you can scale. You can do many different types of decisions in parallel. You can just randomly choose different decision committees. You're not limited to just one group of people. Like in a traditional government, you have just like one parliament or one Congress, right? And all the decisions have to go through them. This becomes a bottleneck. And if you have the ability to just randomly choose out of all citizens decision-making bodies, you don't have this bottleneck. So it's It's a good system, I think. Basically, the way it works is you become a citizen by staking SOR. You get what's called a citizenship bond. Then there's a certain rules that are made, like to prevent spam and things like this. So you can make proposals, but there's certain limits to the types of proposals you can make. And that's set by a rules committee, which is randomly chosen. There is the Agenda Council, which is also randomly chosen, and they look at the current proposals that are out, and they take one of the proposals and they either take it to the next phase, or they just don't move on. So basically, they act like a spam filter in a way. So the Agenda Council will take a proposal that a citizen makes, and any citizen can make a proposal. And then they'll see, like, is it a proposal that we should consider or not? And if they say no, then it just doesn't go on. And then there's interest panels, and the interest panels are basically anyone who wants to contribute. They can give their opinion on some proposal. And then there's a review panel, which is also randomly chosen, and they take the proposal drafts, or they take the proposal ideas and the technical drafts from the interest panels, and they make a holistic proposal. And then there's the policy jury, which will vote on the proposal. So they're also randomly chosen. You could probably do some of these things with AI nowadays. So like, filtering and like combining ideas. But this is still quite experimental, so we'll have to see where it goes. There's also some committees that make set things like policy variables or regulate set regulations. These are Financial Markets Authority Committee and Monetary Policy Committee, and they do different things. There's also another panel called the Oversight Panel that watches everyone else and see if any of the rules have been violated. And if some of the rules have been violated, then you can get your citizenship bond slashed. So you don't want to lose your ZOR. So that's why you want to be careful, right? Anyway, so this first draft of all this has been implemented actually in Nexus. So we will get to try it out and see how it works. Like what are the pros and cons? So first step, of course, will be to test it on the next version of the SORA version 3 test network, which will be set up and announced in due time, I'll say. Okay, cool. So what else do we have? We also, we've got lots of things. I think I gave a good overview of the key components. So just to kind of summarize and to clarify, so Hyperledger Iroha, now we're supporting our own VM, have own consensus on kind of like cool features. There's version 2, which is going to continue to be supported, and version 3, which is new, and they're both being built from the same source code. So version 2 is kind of like a watered down version of version 3. Version 3 will have things like the Parliament, things like data availability, sharding, data spaces, all these different things. Whereas version 2 is just like a single ledger. It's a permission ledger. But there's some potential use cases maybe for that. That's why we're keeping it around. And for SORA Nexus, the way we prevent spam and all this is there's going to be fees, of course, paid in SORA. Even in private data spaces, like for central bank data spaces, they still have to pay in ZOR for fees. But the data space owner can actually have their own fee tokens. So like a central bank may not want their people to go buy ZOR tokens, and like that's too much work. So you can have your own fee token, like in your own CBC, that then is converted into ZOR. Or they could just pay people's fees in ZOR directly, so you can have somebody else pay. there's not really, any decision about what the specific values are going to be. All the instructions are with respect to transfers. So we have what's called a TEU, or transfer equivalent unit. This means that all the instructions that the IVM computes is with respect to, well, it's basically relative to the complexity of a transfer transaction. Because the transfer transaction, you have to, debit some tokens and credit some tokens. So this is like, and it's also pretty normal operation, right? So like people do a lot of transfers. It's a very common thing. So something like, more complex smart contract or something would still be, relative to the transfers. So this allows you to create like a fee structure where a transfer would cost, like, for example, like 1 cent, and then more complex things would just be some combination of this. This is just an example, but we have to decide the specific details. Yeah, there's still a long way to go. The white paper on SORA.org explains a lot of stuff. Everything there's been implemented, at least as the first draft, and we're testing, fixing bugs. There's still, as you can imagine, a lot of details to look at. And then once things are more stable, we'll have a public test network, and then yeah, just keep working and moving forward until we're confident on launch. So when is the public test network? Well, it's pretty close, I would say. There's still a little bit more kind of user interface type of things that need to be done for a test network to be useful. So like things like the our block explorer should be updated. I created a pretty cool demo application in Electron, like just in JavaScript. So we have to kind of maybe finalize that and things like this. So that'll be the first stage, and then we have to add it in the future to Fearless Wallet and do all this stuff. So there's a long way to go. But it's step by step, and we are doing some cool things. We have a few central banks that we're working with, and as a company, I think we are going to use Nexus for all of our new projects, and the current projects that we're using as well. So I think it's pretty cool system. The idea is that instead of having many different systems where you have to like worry about interoperability, you just have like one system, and then interoperability becomes a choice. It becomes, does the administrator of a data space want to allow their token to be used in other data spaces or not? Like, and this type of permission is settable even to like a fine-tuned level. Anyway, I'm going to stop talking and see if you guys have some questions. And in the future, I think we'll do like a more like traditional presentation with like slides and stuff. But this is more like I said, a bit experimental. We never really did a Twitter space before for Iroha. So we're just trying to see how this works and what we can do here. So yeah, if you have some questions, like maybe like raise your hand. I think there's like a hand raised type of icon, like with this reaction type of thing. And then I can try to give you some permission to speak somehow. Any questions? Otherwise, I'm gonna like force William to talk. Do you have a question? Anyway, let's see if this. I'm trying to figure out how this works actually. request. Oh, I see. Okay. I see. You can request to be a speaker. So I granted you access, Grug. Yeah, hello.
Makoto, really awesome. It clarified really a lot of things, to me at least. Regarding SORA Parliament, you mentioned that this is randomly selected and so on. So my question is, how you make sure that like if it's randomly selected, even a moron can join this SORA Parliament and do decisions? How you make sure, how is that possible that an idiot can make decisions and good decisions for the SORA Nexus and the overall community?
Yeah, it's a good question. So, I mean, so SORA Parliament makes decisions, but they do it with respect to rules, right? So there are going to be rules that, of course, these can be updated because it's set by like the rules committee, but like there's still going to be rules, and to change the rules is going to be purposely hard. Because you have to make a proposal, go through all the steps, and then only at the end can the rules be updated and things can be tweaked. But yeah, you want the main way that you prevent like a single person from taking over all this system is basically with the SORA citizenship bond. And even if they did take over, they still would have to follow the rules, or they would get slashed or something. So. This is not really a new system. So like this idea of kind of Sybil prevention using token staking is basically the foundation for proof of stake. So it's nothing too new. I think I think we'll have to test this in the test network and maybe tweak some of the parameters, but. Yeah, the idea is that the citizenship bond would have to be fairly high, because you don't want people to come and take it over completely, because yeah, generally like if you keep it really low, like anyone could create lots of accounts, but generally the people who would create lots of accounts would be kind of bad actors, right? Not because honest participants maybe wouldn't necessarily want to create like millions of accounts or something. So it's pretty it's pretty important to make it the right level for security. But yeah, I mean nothing too new. I mean, we discussed many of these ideas back in 2020. I think the main thing is, also thinking about how, and this is something that we're, studying, like how to include AI, because because it's quite important to, to be future-proof, and also AI can make bad decisions, but it can also maybe augment human work as well. So it's maybe less corruptible in some ways.
Yeah, thanks for the answer. Clarified the question.
Also, this is mostly for the decision-making part of it from a council member, but there's, as far as if you've read the white paper, there's also a mechanism for spam proposals to be slashed in a way. So that's also like another added filter against malicious governance use, right?
Yeah, plus it'll cost money, of course, to make proposals because you have to pay you have to pay transaction fees. So people will I mean, it won't be a lot of money, but it'll cost some money. Like I don't know, $5, $10, something like that. So you wouldn't want to make too many proposals. But I do think AI can help act like a spam filter as well. I saw one system that has like different AIs voting and then taking the aggregate. That's kind of an interesting idea, but this is quite experimental still. We don't really know how reliable AI is going to be, and like then you have to think like what would you do like if the OpenAI because everyone's using ChatGPT in the end. So if if OpenAI API is down, like what do you do? Just stop governance? I mean, it's kind of a hard thing to do, right? I mean, yeah, you could say just make your own AI and put it on chain, make a SORA AI token. I'm joking, but yeah. Anyway, we're still pretty far away from having a practical solution like related to decentralized AI.
Yeah, so can I ask a Moonboy question? Is that also allowed?
Yeah, but remember, I'll ban you in the chat if.
Okay. No. What's like the fair valuation? Everyone wants to know what's the fair valuation of this SORA Nexus blockchain.
The fair valuation is what you pay. I mean,
okay.
Yeah, the market should decide. But yeah, version 3 is going to see a lot of changes. Yeah, not everything is public yet, of course. But yeah, I think that yeah, of course there has to be predictability with the fee token. Otherwise, it's not really useful. I mean, it's a bad usability, right? So you need predictability and kind of future yeah expectations about. What I mean is like if you're trying to use a token for like fees, you have to know how many tokens you need to buy for like an application or something. So you don't want unpredictable fees. You don't want to pay like 1 cent one day and like $50 the next day. That would be like bad usability.
Yeah, I saw that in the white paper. It's written like XOR fee equilibrium. Not sure what it is.
Yeah, anyway, so it's not all public yet. So I think you'll have to wait and see. Come on, we're here for the tech.
Any price predictions?
Oh, come on. Don't make William ban you. But yeah, so we're not going to talk about the Moonboy stuff. But yeah, we'll see how it goes. I'm hoping that also, okay, so I didn't really mention so the source code is not yet public, which is something that we're working on. So we're going to clean it up a little bit, clean up documentation and make the current version public, because Iroha is an open source project. Of course, everything is licensed for open source, and so and what I'm hoping is that once the source code is out, we'll get a lot more contributors and people coming in, adding new features or adding new applications or building things on top of Iroha, and I think that'll be really exciting, because like we're here on Twitter, right? So we have Twitter has what, like 2 billion users or something. So we have 178 followers on Twitter. So out of 2 billion users, 178 follow us. So I'm hoping that that this is something that we'll be able to turn around and get more excitement through through doing new and innovative initiatives like this.
Does anyone other than the group have questions?
Let's see. There's one. Yeah. There's one from our other resident European Moonboy.
Well, good day, good evening, good afternoon to everybody.
Hello.
Hi, Makoto. I did want to ask a Moon Boy question, but what I wanted to ask is, at the moment, the past XOR coins, is that on Iroha too? And is that maybe the possibility that they are not showing in Fearless and in other wallets? That's one question. And the other question is, like the Kensetsu token, is that on Iroha 2, or will that also be moved to Iroha 3? Thank you.
Okay. Yeah, so yeah, regarding Fearless, so I mean, current SORA network tokens show fine for me. So if you don't see SORA network tokens on Fearless, you should change your node. Currently, MOF 3 node is syncing, meaning that you know, the settings were wrong, and like we had to delete the database, and are just resyncing it. So so use MOF1 or MOF2, but don't use MOF3 because you won't see latest data right now. But in a few days, I don't know, sometime next week, it will be back up to the current block. But for now, yeah, don't use MOF3. Regarding other ecosystem tokens, yeah, we have a lot. So these are most likely going to be bridged to Nexus. So, I mean, there's two ways that are, in my opinion, reasonable. So I think people should maybe think about how to do it. But well, I mean, like the community really should kind of decide what to do about the future of the current network. But the idea is that you can either build a bridge where you could just bridge to Nexus, or you could do like a one-way transfer, meaning you basically burn the token and then use the proof of burn to get it to claim the token on Nexus. So there's pros and cons of these solutions. So we kind of have to think about it, I think, because you know, it's a lot of overhead and also cost to keep current network running. Like, do we want to do it forever? That's I think a good question. So anyway, we don't have to decide it now. I mean, like it's possible to start with a bridging, and then later, you know, do like a one-way burn, or you could do like something like similar to CCTP. So that's Circle's cross-chain transfer protocol, where you burn on one network and then you can mint tokens on another network using a proof of the burn. And something like that could also be built between Nexus and other networks like SORA version 2, for example. So anyway, the key point is, yeah, there'll be a way to move your tokens between the networks. So you'll be able to move Ken tokens or whatever to SORA version 3, and yeah, any kind of token you want. Like yeah, so hopefully that makes sense.
Grazie tutti, Optimus.
Yeah. So feel free to make some new tokens on SORA version 2. Like, yeah, it's not going away right now. So yeah, and you know, other tokenomics I think, you know, need to be publicly announced. So like, you know, PSwap and balance, stuff like that. But yeah, I'm not going to leak information right now. But yeah, thanks for the question. I think it's pretty I think it's a pretty good question. So so I appreciate that. Let's see here. There's another guy, Red. It looks like did you want to ask a question about ERC tokens or something? it's a fine if if you want you can ask. I think trying to find user. There's one user that wanted to ask something about transferring ERC tokens to Nexus. So yeah, to do this we need a bridge to Ethereum. So kind of looking forward, our ecosystem is going to be doing a lot of stuff with with Ton, like just because of TonSwap and the fact that KUSD is going to be on TonSwap. So basically what that means is that we have to have some interoperability with Ton, and Ton already has bridges to a lot of other ecosystems, so we might just use their infrastructure to go to legacy chains. But yeah, we'll have to see. I mean, from my personal standpoint, I personally don't think that having a lot of bridges is a high priority for Nexus, just because the idea is that well, the whole point of Nexus is you don't need other networks, like right? So like you can do all the transactions in the world on this one system. Why would you need like a network to like a 10-year-old system? But yeah, anyway, so a lot of capital is still on Ethereum. I get it, and that's why, yeah, there has to be some interoperability. There's no way around it for Ethereum, but I don't think we'll support like a lot of these like niche networks and stuff like that. But it's open source project, so other people could build their own interoperability protocol or bridge and contribute it. But you have to be really careful. Some networks, are very susceptible to cybersecurity issues. Like, for example, any kind of proof of work network would be quite scary to support, including Bitcoin, because well, there could be different attacks against consensus. We saw this with Monero, right? Where I forget the name of the project, but some proof of stake project basically took over a large percent of the mining and was able to do like a block reorganization, things like this. And this is quite it's quite scary. So you have to be very careful not to yeah, get too much exposure to things like that. But yeah, good questions. Yeah, I'm sure everyone wants to know, like, what will happen to current tokens? Like, how do we move that? Yeah, I mean, Sora, we work hard. We work hard on the project for many years now. But it's been hard to get a lot of traction, a lot of users on Sora. But that's why we're focusing kind of like on these more of like a blue ocean type of thing. Like, so working with governments that we have relationships with, it seems to be a good way to get users, governments and corporations. Because if we try to go and compete in like crypto space, there's so many projects out there, and they have a lot of capital, a lot of backing, and it's a little bit hard to take over that space. But on the other hand, if we take over more traditional spaces, working with what we've been doing, then the crypto projects will come. So but not the other way around. So just because you have a lot of crypto users doesn't mean that central banks or companies want to work with you. So, but the opposite is kind of, I think, true. So that's part of the idea of Nexus as well. Like, you kind of get to the point where all these people have an account that's on Nexus, and then as soon as you have an account on Nexus, I mean, you have an account and you can do anything. You don't have to be limited only to the CBDC. You can do, work with other tokens, work with other projects, and you're not limited to just crypto stuff anymore, because using the decentralized infrastructure, the SORA nodes, you've got like video streaming, you've got data storage, website hosting, computation. All these things are possible. which is pretty cool. I think it's like really quite awesome. So should be really interesting to see how the next few weeks go. It's the end of the year, of course, so people are not doing too much serious, but yeah, hopefully people will be able to start testing on public testnet and then giving us feedback, and then yeah, that'll help us to launch as soon as possible. But yeah, our go-to-market strategy is not really aimed so much at the crypto side, but rather working more with some of the corporate and enterprise side, because that's a little bit easier. I mean, it's kind of where our where our expertise lies, right? And there will be a SORA Economic Forum this year, so we're going to be hosting that in December. It's not going to be in November, but yeah, just working on the final plans, because yeah, I have some other commitments as well in December, so it's going to be a pretty busy month. It's going to be a pretty wild ride, but I think it'll be quite cool. And hopefully what you like a lot of the research and work that we've done on Nexus, it's been a lot of work, and those on our team who are here kind of know how much work we've done. So hopefully it is something that the world finds useful and can improve state of humanity, and also create a new world economic order, because we do need a different system than what we have now. Any other questions? Otherwise, I'm gonna go get some food. It's kind of hungry here. Cool. So yeah, if there's no other questions, so in the future we will do a proper kind of like explanation and presentation with like slides and like math and all this stuff. But yeah, I just wanted to make some time tonight to kind of explain some of the progress, just so that people kind of know what's going on. And yeah, if you want to contribute, Iroha is open source. It's part of the Linux Foundation Decentralized Trust, and anyone is free to contribute. And if you have some good ideas, or new feature ideas or requests or whatever, you can either follow official like LFDT channels, or you could just like write something here on Twitter. It's fine as well. So yeah, it'll be interesting to see like what kind of interest we can get in the future, and if we can start to grow our Twitter presence as well. I think that'll be really cool. And it also, in the future, it'd be great to have other contributors to Iroha speak. And I think we'll try to do like more regular spaces. I'm kind of disappointed that this kind of Twitter space interface is so limiting. Like I can't really do like a lot of stuff that I could do in other platforms. And so, but there are pros as well. So like, maybe Grok will listen to all of our stuff and help spread the word. So we'll see where it goes. Anyway, have a good evening, everyone. Happy Friday. And yeah, Shabbat Shalom. Yeah. So have fun, everyone. See you.